Hey guys, welcome. 2.4 video. Let's get to it. Solving equations with variables on both sides. So today we're going to solve equations with variables on both sides, and we're going to identify equations that are identities or have no solutions. Okay? So we'll talk about what an identity is when we hit it. So let's get to examples. Yeah! That was way too much excitement for a math video. Okay, well, let's get started. Solving equations with variables on both sides. Well, if you believe it or not, we have 5x plus 2 and 2x plus 14. So, when we have variables on both sides, we want to move them over to each other. Now, we might have already talked about this in class, but we're going to talk about it again. We're going to get a little bit more in depth with how we do some of this stuff. So, I always like to say, let's do the light lifting, okay? I like to say it's like the sheep. The variables are the sheep. We got to get them all the same side. It's going to be easier to move the sheep that there are fewer of. So I'm going to take the 2x, and to get rid of it, we're going to subtract the 2x from one side. That makes it cancel. We subtract from the other side, okay? And once we've done that, we're left with 3x plus 2 equals 14. Then we're going to go ahead and subtract the 2 from both sides. That's a 2, as ugly as it is. 3x equals 12, and then divide by 3, and we're going to get x equals 4. Okay? Boom, boom, boom. Thank you, thank you. There it is. This is an example of having one equation. X equals one answer. It doesn't mean it has to be a whole number. It could be a fraction, but we have one answer. We're going to look at two more scenarios where x is not going to have one answer. Let's go ahead and take a look. Okay, so let's go ahead and solve this. Before we move everything to the same side, we have to go ahead and take care of this distributive property, which we did yesterday. So 2 times 5 is 10x. And don't forget to multiply the 6 by 2 as well. We get 12 equals 10x and 12. All right, hold up a minute. This is an interesting situation. Do you notice that both sides of the equation are the exact same? 10x plus 12 and 10x plus 12. This means we have what's called an identity. So an identity is when we have the exact same picture on one side as the other, which means any value of x I plug in is going to work. Think about it. Plug in 2. You're going to get 20 plus 12 on one side and 20 plus 12 on the other side. That's going to work. Put in 10. 10 times 10 is 100 plus 12, and then 100 plus 12. Any number is going to work. We could actually go ahead and solve this. Subtract 12 from both sides. What happens? Cancel, cancel. We get 10x equals 10x. We should already be thinking this is a dilemma. Subtract 10x from both sides. We get 0 equals 0. Is that true? Yes. That means we have infinite amount of solutions. Any value of x you want to plug in, you are going to get a correct answer. So we call this an identity problem, but we also have the answer of infinite solutions. You don't actually say the answer is an identity. No, you say the answer is infinite solutions, because it could be any number for x. Fractions, decimals, whatever, negative numbers, it all works. Now let's look at the opposite of that. Okay, let's take a look at this problem. So first, we have to combine like terms, negative 3m and a positive 12m. That's going to give us 5 plus 9m, I believe. Yeah. And 9m minus 4. Okay, now, who should move? Who's smaller, 9m or 9m? They're the same. So let's go ahead and subtract one of them. You got to get them all to the same side. But what happens is it cancels out both. And then we're left with negative 4 equals 5. Is that true? No, it's not true. In fact, if we try to do this, this would just end up nowhere. This means any number I pick for m will never work. Okay? So this is a situation, so this is not true. Boo, sad face. So this is a no solution problem. So we can get a solution where it is one solution, like our first problem today. We can get infinite solutions, like our second problem, and then we can get no solutions, like our third problem. Okay? All right, this is your captain, Captain O'Captain, signing out for another great day. I love math, math is cool. Look at me, jiggle my head. Wow! Wait, stop. 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 The first order is the best. Okay, I should probably go home.